Welcome to the fourth lesson in Session 7, Solving Rational Equations. A rational equation is an equation where the variable is included in the fraction. To solve a rational equation, we must first completely factor all denominators. Once everything is factored, we have to identify what the least common denominator is between all the fractions in our equation. Next, we're going to rewrite the equation without fractions. There's a few ways to do this. For our lesson, we're going to multiply each term on both sides of the equation by the least common denominator. What this does is it allows us to write an equivalent equation without fractions, allowing me to solve the equation. Finally, we have to check for extraneous solutions. An extraneous solution is a root of a transformed equation that is not a root from an original equation. So although it may appear using our sound algebra skills that we have come up with an answer, when substituted back into the original equation, we'll see it is actually not a solution to the equation. Possible extraneous solutions are values of x that make the denominator equal to 0. And another term that we need to understand is the domain. A domain are possible input values. For our first example, we have 15 over x plus 3x minus 7 over x plus 2 is equal to 9. So both denominators are already prime, so the LCD is the product of those prime factors. So our LCD in this equation is going to be x times the quantity of x plus 2. Now we have to multiply each term on both sides of the equation by the LCD. So 15 over x gets multiplied by the LCD, 3x minus 7 over x plus 2 gets multiplied by the LCD, and 9 gets multiplied by the LCD. Doing so gives me 15 times the quantity of x plus 2, because the x's will cancel out, plus x times the quantity of 3x minus 7, because the quantity of x plus 2's cancel out. And on the right side of the equation, nothing's going to cancel out, so we have 9x times the quantity of x plus 2. Now I have to distribute all that out and solve it. So we distribute, collect everything on one side of the equation, identify that I have a quadratic equation, and need to figure out how I'm going to solve it. I notice that each of those terms is divisible by 2, and my leading coefficient is negative, so the first thing I'm going to do is divide both sides of the equation by negative 2. That leaves me with 3x squared plus 5x minus 15. Now, to solve this quadratic equation, we're going to have to use the quadratic formula and simplify as much as possible. Using the quadratic formula gives us negative 5 plus or minus the square root of 205 all over 6. I cannot simplify the square root of 205, so there's my answer. Negative 5 plus or minus root 2 over 5 all over 6. Now that answer is not going to produce a 0 in the denominator. So if I would have had an answer of 0, that would have produced a 0 in the denominator. Or here, if I would have had an answer of negative 2. I would have had to reject those answers because those would have been extraneous solutions. In this case, my solution is not extraneous. In the next example, I have 1 over b plus 1 over b minus 1, and that's going to be equal to 2 over b squared minus 1. So recognize on the denominator on the right side of the equation, I can factor. So I always have to start by factoring. Now I have to identify the least common denominator, and in this case my LCD is going to be the quantity of b plus 1 times b minus 1. Multiply all three terms on both sides of the equation by the least common denominator. So when I multiply by the first fraction, the b plus 1's will cancel out, and I'm left with b minus 1. When I multiply by the second fraction, the b minus 1's are going to cancel out, and I'm left with b plus 1. And on the right side of the equation, the entire denominator cancels out, and I'm left with 2. So I'm left with b minus 1 plus b plus 1 equal to 2. And when I simplify, I've got 2b equal to 2, therefore b is equal to 1. However, if b were equal to 1, notice this fraction, 1 over b minus 1, and the fraction on the right, 2 over b squared minus 1. If I input 1 into either of those into the equation, I'm going to get a 0 in the denominator, which makes my whole expression undefined. So I have to determine that 1 is an extraneous solution, and we're going to reject it. So this equation has no solution. Lastly, we're going to study proportions. A proportion is a special type of rational equation where two fractions are set equal to each other. To solve a proportion, we're going to find the cross product. So we have a over b is equal to c over d. The cross product would be a times d equal to b times c. So for my first example, I have 2x plus 1 over 2 equal to x plus 2 over 5. So I've got two fractions that are equal to each other. So identify I do have a proportion, and we can identify the cross product. 2x plus 1 times 5 gives us 10x plus 5, and 2 times the quantity of x plus 2 gives us 2x plus 4. Now we just have to simplify and solve. Subtract 2x from both sides gives us 8x plus 5 equal to 4. And when we subtract 5 from both sides, we have 8x equal to 1. Divide both sides by 8, and x is equal to 1/8. Since there is no variable in the denominator of the fraction, there's no chance for extraneous solutions. So I'm going to accept the answer of 1/8. We move over to the right, the last example for this session. We've got 1 over x minus 5 equal to x over x squared minus 25. So we got to find the cross product. Doing so gives me x squared minus 5x is equal to x squared minus 25. We'll subtract x squared from both sides, and we'll see that they'll cancel out. We're left with negative 5x equals negative 25. Dividing both sides by negative 5 gives me an answer of 5. However, if x were equal to 5, both of these denominators would be equal to 0, therefore the fractions would be undefined. So I have to reject 5 as a possible answer, and again, this equation has no solution. So that wraps up the fourth lesson in session 7. Good luck on the quiz, and please email us if you have any questions.